Ditambah lagi saya hitungannya sekarang bisa kerja sebelum saya wisuda.
Pos Indonesia.
Terus untuk teman-teman semuanya juga yang berminat untuk masuk di ULBI boleh banget, karena siapa tahu teman-teman bisa punya rezeki kayak aku, ketika lulus nanti bisa langsung ditempatkan dan langsung bekerja di seluruh Indonesia. Bisa jalan-jalan.
Universitas Logistik dan Bisnis Internasional berdiri di bawah naungan Yayasan Pendidikan Bakti Pos Indonesia, merupakan perguruan tinggi hasil penggabungan dari Politeknik Pos Indonesia dan Sekolah Tinggi Manajemen Logistik Indonesia. ULBI adalah lembaga pendidikan yang berfokus pada bidang logistik, manajemen rantai pasok, dan tata niaga elektronik. Kami memberikan pendidikan yang berkualitas dan relevan dengan kebutuhan industri, serta memiliki koneksi yang kuat dengan PT Pos Indonesia di bidang jasa kurir, logistik, dan transaksi keuangan. Pilihan jenjang pendidikan Diploma 3, S1 Terapan, dan Sarjana di dalam Fakultas Sekolah Vokasi dan Fakultas Logistik, Teknologi, dan Bisnis. Bergabunglah bersama kami, Creating Best Talent for Bright Future.
Dengan penuh pengabdian.
Nias, Gunung Sitolik,
Komodo, Nusa Tenggara,
Kuta Cane, Aceh,
Tanjung Redep, Kalimantan Timur.
Terima kasih untuk ULBI yang sudah mendidik anak-anak kami, sudah menjadi manusia-manusia yang luar biasa sehingga mendapatkan kesempatan untuk bekerja di PT Pos.
Ditambah lagi saya hitungannya sekarang bisa kerja sebelum saya wisuda.
Pos Indonesia. Terus untuk teman-teman semuanya juga yang berminat untuk masuk di ULBI boleh banget karena siapa tahu teman-teman bisa punya rezeki kayak aku ketika lulus nanti bisa langsung ditempatkan dan langsung bekerja di seluruh Indonesia. Bisa jalan.
Universitas Logistik dan Bisnis Internasional berdiri di bawah naungan Yayasan Pendidikan Bakti Pos Indonesia, merupakan perguruan tinggi hasil penggabungan dari Politeknik Pos Indonesia dan Sekolah Tinggi Manajemen Logistik Indonesia. ULBI adalah lembaga pendidikan yang berfokus pada bidang logistik, manajemen rantai pasok, dan tata niaga elektronik. Kami memberikan pendidikan yang berkualitas dan relevan dengan kebutuhan industri, serta memiliki koneksi yang kuat dengan PT Pos Indonesia di bidang jasa kurir, logistik, dan transaksi keuangan. Pilihan jenjang pendidikan Diploma 3, S1 Terapan, dan Sarjana di dalam Fakultas Sekolah Vokasi dan Fakultas Logistik, Teknologi, dan Bisnis. Bergabunglah bersama kami, Creating Best Talent for Bright Future.
Universitas
pengertian.
Nias, Gunung Sitoli,
Komodo, Nusa Tenggara.
Kuta Cane, Aceh.
Tanjung Redep, Kalimantan Timur.
Terima kasih untuk ULBI yang sudah mendidik anak-anak kami, sudah menjadi manusia-manusia yang luar biasa sehingga mendapatkan kesempatan untuk bekerja di PT Pos.
Ditambah lagi saya hitungannya sekarang bisa kerja sebelum saya wisuda.
Pos Indonesia. Terus untuk teman-teman semuanya juga yang berminat untuk masuk di ULBI boleh banget karena siapa tahu teman-teman bisa punya rezeki kayak aku ketika lulus nanti bisa langsung ditempatkan dan langsung bekerja di seluruh Indonesia. Bisa jalan.
Universitas Logistik dan Bisnis Internasional berdiri di bawah naungan Yayasan Pendidikan Bakti Pos Indonesia, merupakan perguruan tinggi hasil penggabungan dari Politeknik Pos Indonesia dan Sekolah Tinggi Manajemen Logistik Indonesia. ULBI adalah lembaga pendidikan yang berfokus pada bidang logistik, manajemen rantai pasok, dan tata niaga elektronik. Kami memberikan pendidikan yang berkualitas dan relevan dengan kebutuhan industri, serta memiliki koneksi yang kuat dengan PT Pos Indonesia di bidang jasa kurir, logistik, dan transaksi keuangan. Pilihan jenjang pendidikan Diploma 3, S1 Terapan, dan Sarjana di dalam Fakultas Sekolah Vokasi dan Fakultas Logistik, Teknologi, dan Bisnis. Bergabunglah bersama kami, Creating Best Talent for Bright Future.
Universitas
dengan penuh pengabdian.
Nias, Gunung Sitolik,
Komodo, Nusa Tenggara.
Kuta Cane, Aceh.
Tanjung Redep, Kalimantan Timur.
Terima kasih untuk ULBI yang sudah mendidik anak-anak kami, sudah menjadi manusia-manusia yang luar biasa sehingga mendapatkan kesempatan untuk bekerja di PT Pos.
Ditambah lagi saya hitungannya sekarang bisa kerja sebelum saya wisuda.
Pos Indonesia.
Terus untuk teman-teman semuanya juga yang berminat untuk masuk di ULBI boleh banget karena siapa tahu teman-teman bisa punya rezeki kayak aku ketika lulus nanti bisa langsung ditempatkan dan langsung bekerja di seluruh Indonesia. Bisa jalan.
Universitas Logistik dan Bisnis Internasional berdiri di bawah naungan Yayasan Pendidikan Bakti Pos Indonesia, merupakan perguruan tinggi hasil penggabungan dari Politeknik Pos Indonesia dan Sekolah Tinggi Manajemen Logistik Indonesia. ULBI adalah lembaga pendidikan yang berfokus pada bidang logistik, manajemen rantai pasok, dan tata niaga elektronik. Kami memberikan pendidikan yang berkualitas dan relevan dengan kebutuhan industri, serta memiliki koneksi yang kuat dengan PT Pos Indonesia di bidang jasa kurir, logistik, dan transaksi keuangan. Pilihan jenjang pendidikan Diploma 3, S1 Terapan, dan Sarjana di dalam Fakultas Sekolah Vokasi dan Fakultas Logistik, Teknologi, dan Bisnis. Bergabunglah bersama kami, Creating Best Talent for Bright Future.
Logistik dan bisnis internasional, wadah kegiatan pembangun bangsa berdasarkan Pancasila, siap mengemban amanah, penyaji insan kompeten, kritis kreatif dan inovatif, berjiwa satria sejati. Chandra di muka menemukan karakter dan keterampilan, disiplin dan kerja keras, meretas segala kendala. Di peradaban dunia yang syarat dengan dinamika, berbentuk kualitas ilmu dan integritas, sambut hari depan dan gemilang.
Next slide. Nah, ini mungkin sedikit promosi. Saya hanya fokus pertama tidak saya pulang dulu, langsung saya tawarkan dia punya slide.
Katolik,
Komodo, Nusa Tenggara.
Kutacane, Aceh.
Tanjung Redep, Kalimantan Timur.
terima kasih untuk ULBI yang sudah mendidik anak-anak kami, sudah menjadi manusia-manusia yang luar biasa sehingga mendapatkan kesempatan untuk bekerja di PT Pos.
Ditambah lagi saya hitungannya sekarang bisa kerja sebelum saya wisuda.
Pos Indonesia.
Terus untuk teman-teman semuanya juga yang berminat untuk masuk di ULBI boleh banget karena siapa tahu teman-teman bisa punya rezeki kayak aku ketika lulus nanti bisa langsung ditempatkan dan langsung bekerja di seluruh Indonesia. Bisa jalan.
Universitas Logistik dan Bisnis Internasional berdiri di bawah naungan Yayasan Pendidikan Bakti Pos Indonesia, merupakan perguruan tinggi hasil penggabungan dari Politeknik Pos Indonesia dan Sekolah Tinggi Manajemen Logistik Indonesia. ULBI adalah lembaga pendidikan yang berfokus pada bidang logistik, manajemen rantai pasok, dan tata niaga elektronik. Kami memberikan pendidikan yang berkualitas dan relevan dengan kebutuhan industri, serta memiliki koneksi yang kuat dengan PT Pos Indonesia di bidang jasa kurir, logistik, dan transaksi keuangan. Pilihan jenjang pendidikan Diploma 3, S1 Terapan, dan Sarjana di dalam Fakultas Sekolah Vokasi dan Fakultas Logistik, Teknologi, dan Bisnis. Bergabunglah bersama kami, Creating Best Talent for Bright Future.
Universitas Logistik dan Bisnis Internasional, wadah nyata pembangun bangsa berdasarkan Pancasila, siap mengemban amanah, penyaji insan kompeten, kritis kreatif dan inovatif, berjiwa satria sejati, chandra di muka menemukan karakter dan keterampilan, disiplin dan kerja keras, meretas takkan dalam di peradaban dunia yang syarat dengan dinamika, berbekal kualitas ilmu dan integritas, sambut hari depan dan gemilang.
Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh. Good evening, ladies and gentlemen, and
Recording in
our beloved
progress.
students. Welcome to ULBI Global Lecture, the series proudly presented by Universitas Logistik dan Bisnis Internasional ULBI and initiated by our rector, Professor I. Nyoman Pujawan. Good evening, Professor Nyoman.
Good evening, Bu Widya.
Okay, so today is Friday, May 23rd, 2025, and the sixth episode, and it is part of our international collaboration program to enhance global insight and academic exchange. Allow me to introduce myself. My name is Widya Resdiana, and I'm very honored to be your host for today's lecture. Before we begin, I would like to read another pantun again. Okay. So, morning sun shines golden bright. Birds fly high with joyful tone. Let's gather here with minds so light to gain new knowledge from our sixth episode of Global Lecture. Tonight, we are deeply honored to welcome our adjunct professor from Purdue University, USA, Dr. Muhammad Rizki Oktavian. He will be delivering a lecture on the topic From Raw Data to Predictions, Fundamentals of Machine Learning and the Data Pipeline. This session will surely benefit for those who are interested in artificial intelligence, data processing, and the real-world applications of machine learning. Before we move forward, please allow me to remind all participants to mute your microphone during the session. Use the Zoom chat room to ask question during the Q&A session later, or maybe you can raise your hand and talk directly to Dr. Rizki tonight. And please rename your Zoom ID with your full name and institution. Okay, for your information, this lecture is free and open to all ULBI students and anyone who is interested. And we thank you all for joining us today. So, on behalf of our rector, Professor Nyoman, I officially open our today's lecture. Now, let's move on to our highlight of tonight. I would like to say hello to Dr. Muhammad Rizki.
Yeah, hello everyone. Hello, Bu Idai. Yeah, nice to meet you
Hello,
all.
how are you
Yeah,
today?
good, good. It's very good.
Okay, nice to meet you too.
Yeah, you too. Thank you.
So it's in the morning there, right?
Yeah, it's morning. It's 8 a.m. here, and I believe it's 7 p.m. over there.
Okay.
So good evening, everyone.
Yes. Okay. Okay, so Dr. Rizki, are you ready to start your lecture today?
Sure. Yeah, I have my PowerPoint ready. Okay, let me share my screen if I can. Okay, so I hope everyone can see this.
Yes, we can. And allow me to remind
Okay.
you that you have 1 hour to deliver your lecture.
Sure, yeah. Thank you. Thank you, Bu
Okay.
Widya. Yeah.
Yeah, let's start.
Okay. Okay. Thank you, everyone. Again, my name is Rizki, and thanks again for all the introduction. It's very nice, and it's a good experience for me here, too, for the ULBI Global Lecture. So maybe we're going to, sometimes we mix with Bahasa Indonesia as well, if need to. So don't worry if you want to stop me or ask question in Bahasa or want to do it in English, feel free to do so. But yeah, anyway, the idea of today's lecture is just to, give some layout on the whole process of machine learning and the data pipeline. So we call it pipeline because, it's like an actual something moving around one location to the other. For data, it's like oil or all other liquid like that. So we move from raw data into the pipe, and then we get the final or clean data, or in the end we put machine learning into that process, and then we get the prediction to the end of the pipe. So we call some people call it pipeline. So yeah, so this is what we're going to talk today. We're going to explain like it's mostly fundamentals because we only have 1 hour here, but feel free to ask question if you want anything more details later on. But yeah, a little bit about me. So a little bit about the outline today is first introduction. So what is a little bit about me and also about the AI and machine learning and what connection with this today lecture. Then we'll have a description on data processing and exploratory data analysis. So we're going to talk about that as well. Then supervised learning and unsupervised learning. So that's the last two things that we're going to talk today with related to the machine learning method. So okay, about me. So and a little bit about mindset.id because we initiate those in 2023. And I'm the one of the initiator in there with some friends and colleagues in the US, mostly Indonesian that has finished study in the US. So we'll start a mindset.id to focus more on educating what we learn in here, especially in the STEM field. So I also hold AI certificate from United States Artificial Intelligence Institute. So if everybody want to know more about AI, I'm happy to talk about that. So yeah, and that's currently in the hype of today technology. We see AI every day. We see everything about the generative AI, especially. For my education background, I got my bachelor or S1 dari Universitas Gadjah Mada. So I got my bachelor of engineering there in nuclear engineering, but also I learned a lot about computer science as well during my master and PhD in the US.
Halo,
I
apa Jack?
master in University of Michigan and PhD at Purdue University when I'm at now. So my field is mostly about artificial intelligence application on energy domain. But also because AI is very broad, so you can implement to anything. So that's gonna be like very generic, talk today about what we can do with machine learning and artificial intelligence, especially related to the data that we have right now. So again, if anyone interested in learning more about AI or any other STEM or science, technology, engineering, and math, materials, feel free to check mindstem.id website or Instagram or YouTube. But yeah, that's all for about me and mindstem.id. But next, I'm going to start into introducing everyone to what is AI. So we know a lot about AI. We heard a lot about it, but it seemed like sometimes we kind of forgot like the actual definition of that. So AI is actually a branch of computer science. So it's still part of computer science, but focus more into like how we develop a system or machines or maybe algorithms that can mimic what human will do with their intelligence. So that's why it's called artificial intelligence, because it has the intelligence system like what human does, but also it's artificial, means that it's come from machine, it come from computers. So there are if you make a big diagram like this for AI, so we know that machine learning is inside it, and then deep learning is even smaller subset of machine learning. So if anyone has learned about deep learning is actually just neural networks that has more than 2 layers. So it's like that's why it's deeper than the regular machine learning application. And we have the new and the latest development of natural language processing, which is kind of like a bit intersection of deep learning, because NLP use languages instead of focusing on numeric or numbers. So it uses more about words, about the letters instead of about the numbers and other things like what we learn in machine learning actually. So the intersection of those combine and give birth into large language model and conversational AI, like what we have in ChatGPT and kind of like that. So it's kind of like small set of artificial intelligence, because sometimes is kind of like a lot of applications as well. It's not just like what we have in ChatGPT, but also in other domain as well in AI. There's a lot of those application. So we don't want to focus on one specific thing in here that I have in this diagram, but instead of we're going to discuss more in general how we have from data and then how we process it into the machine learning application into that. So and again we talk about machine learning, which is kind of part of AI, but let me give a little bit more description or explanation on what's the difference between traditional programming and machine learning. So traditionally, when we do programming, so if anyone learn, any programming languages before, like maybe C or C++ or Python, which is kind of a popular programming language right now. So in general, when you want to make something, you have some data, and then you have some program that you put into the coding process on the computer, and then you get some output of it. So yeah, for example, if you want to here, for example, if you want to get a let me get some simple example. If you want to get calculate, for example, the interest of your of loan, for example, like, or you put the input, like, which is how much you will take off from the bank, and then how much the interest, and then you put some program into that calculating those with some simple function from accounting. Then you put that into write a program on that, then put that run in the computer, then you get the output of your how much you will need to pay in the next, I don't know, 5 years or 10 years. With machine learning, it's different. You have some data and some output examples. For example, that what I mentioned earlier, that you have you have X and Y. If we talk about like in mathematical domain, you have X and Y. Then you put a computer in it. Then you have a program after you train machine learning model. So whenever you have input and output examples, which will later we call them supervised learning process. So you will get a model or also close to the program that we can use later on. So that way we can use that in the next applicable application for the data that we train into the model for the machine learning application. Yeah. Now I think that's a bit about the introduction for AI and machine learning. But now we will talk a little bit more details about how we process the data that we have, and then more into like exploratory data analysis, which is kind of like another approach to understand the data and then how we can process that further based on that. Data processing, we have, so this is like kind of like a rough process on the, we can transform raw data into processed data for analysis. It's Lawton 2022 mentioned about there are 6 steps on those, which which actually can be made of several sub-steps. But here, first, you have if you have the data, for example, you have a weather data, you have in weather data, you have the temperature, or you have the wind speed, and you have the rain precipitation, like how much rain you will get in that day. So and then from that raw data, how we can analyze those. First, you profile the data. Profile mean that you put some identity to the data. For example, for weather data, you will need to know because weather is specific. For example, you can have weather data in different locations, for example, in Jakarta, and then in East Java, or maybe in other location in Indonesia, it might be different. You need to profile those, separate those into different location, or maybe different time as well. So we can have all of those. And the data cleansing is the process or clean the data, because when you have raw data, especially, for example, for weather data that I mentioned, so you have data from the measurement from BMKG, for example. They have a system that record the data, the weather data. Then from the weather, they have, it's possible to have outliers. It's possible that you have some errors in the measurement system, or in the calculation system, or the computer system that they have. So we need to clean those up, then reduce the data to the data reduction is a process to reduce the data into only features or only parameters that we are interested in. So because like we have, usually in raw data, we have a lot of columns and rows, and sometimes we don't need all of them, so we can reduce the faster with data reduction, so it's easier to process those further. And then data transformation, we need to transform the data into the format that we are going to use. For example, if the data in Excel and then we would like to have it in text format, we need to transform those, or we need to, change those into different format based on that. And maybe we're going to need data enrichment as well if we need to combine data with another data set. For example, this one, we have weather data, but we also need a geolocation data. We need to know which actual coordinate of the city, for example, Jakarta, which coordinate is Jakarta, and which coordinate is Surabaya, for example. We need to compare those, then we enrich those combined with the other data set. Again, that's just an example. It can be anything, like maybe anyone can have different approach for that as well. Then data validation is the last step. When after you process all the data, you validate those, whether you already get everything like what you want, or you want to add more thing into that. So yeah, that's the data processing in general. And also there's an important step on the data analysis called EDA, or exploratory data analysis, which is kind of a kind of important step in machine learning, that after you understand the data, the problem, you need to inspect the data further and try, after we process the data, we try to understand the characteristics of the data, the patterns between the data. If I'm using the example of the weather data that I mentioned, the weather in one location maybe have the same pattern with another location, depending on the longitude and latitude of that location. Maybe in the same province in Indonesia, they have similar patterns on those. We can kind of understand by using the data alone, without going into like the detailed machine learning later on. But those will help us to understand what we learn between parameters, between variables. So ADA, like, a process you have from raw data here, and then you try to understand the problem and the data that you have, and then inspect the data, then handle what is missing in the data, whether you need to add more data, or you can remove some of the data that you want. Then can the data characteristic do transformation? Transformation means that you move or you process the data from one format to the other format. For example, if you have tabular data and you wanted to make it like a graphic or plot or a diagram, you can also do that. And also in the related to the visualization as well, you visualize the data, and then we can have the data visualization on those, and then get the relationship between the data. A simple way is to make a scatter plot, or make a bar plot, or make a column plot. There's a lot of plotting strategy depending on the data that you want to understand, and what the conclusion that you want to achieve from that. Then there's another process to handling outliers. If you have outliers into your data, you can handle those either by removing those or by any other approach that you want to do. So And the last step is, this is the most important step, is how you communicate your findings. After you get all the data processed, you get all the insights, and how you communicate those, either using your, maybe writing an article, maybe writing a paper, maybe writing a lot of things, a report or something like that. That's also an important step in this case. Okay, so and then what's the goal of EDA? First, we can catch the data errors very early, because when you see the data, you know, like, especially if you understand like what it should be in the data, like you have the knowledge of that field on that domain. For example, I give an example of weather data in Indonesia. You know that the temperature in Indonesia is maybe around, I don't know, like 20 or 30 degrees Celsius. If it's like, you know, if you have data that is maybe 0 degrees Celsius or maybe 5 degrees Celsius, it might not be correct. It might be in some certain location, but most of the time, Indonesia always has like around 20, 30, or maybe 35 degrees Celsius. So we know we know the possibility of data errors, and we can catch them faster if we analyze the data early. Then this is just a, you know, illustration of those. You can detect the data error. You can check your analysis assumptions. So if you have hypothesis on a certain data distribution as well, you can check those. And then if you decide to use machine learning or a statistical model, the EDA can help into those, because you have an idea of the data format or the data patterns into that. Then you can have initial selection of what the appropriate model for that. If the model is something like this, so it's very clear to me that we need to use linear regression instead of maybe, I don't know, hyperbolic, or maybe higher order regression process. So this one is linear. You can just use some linear function to follow that. That's just an example. And again, you will know the relation between variables with that. So this just an example. If you do data distribution analysis, you will see in the data, for example, and then you cannot. We need to check the missing data. This is an example. Most of the time you will see from raw data, you'll see some error like this. NaN means like not a number. So it means like we need to clean this data either by fabricate or not fabricate. Maybe add data, maybe average data, or maybe add some, or maybe remove all of those together if we don't really need more data on the missing data. So we can clean the B, C, D rows here, then we just have 2 rows used in our analysis. That's also possible. Then we have outliers analysis by plotting the data. For example, this is like a scatter plot. Then you plot that, then you know that, for example, this data is over here, then it means that it's outlier. So we can clean this data early in that case. And then we can understand the patterns on the data, and we can understand what data types that we have. This one is a sample. You have customer number in the integer format. It means like in the 1, 2, 3, 4, 5, 6, and so on. Then we have customer name and so on. We have we can understand the data, and it also helps us in visualizing the data. And also help into again into the understanding the relation between parameters in that case. And then data quality. We can also learn the data quality based on the exploratory data analysis. We can learn from that, which is interesting. And then what types of EDA we can use. So it depends on the data. Sometimes we just need to visualize single variable or multivariable, depending on the data that we have. If it has like a deep connection between variables, we can plot together different variables at once. And it can be, we can use non-graphical and graphical format. Non-graphical means it's just text or just number. If it's a numeric data, If it's graphical, means that you do that by plotting the data into like some diagram or some scatter plots or some other plot that you can have depending on the data format. Okay, so with this with this separation here, we see like you can have like single multi-variable, you can have non-graphical or graphical approach. So we have four approaches to do EDA, which usually people combine those together because sometimes one method is better than the other, and one method is usually also complementing the other method. Which is good because we can use any of these and we can get like better understanding of the data that we have. Okay, so this is example of single variable non-graphical. So it means just tabular data or just text data, just showing all the numbers in here. Some method will be like using categorical data table. It's just an example of it. So this is an example of student college data. So how many the statistics and then proportion and percentage. So you can see all of this. Then characteristics of quantitative data. You can get it in this EDA process, in the exploratory data analysis process, especially central tendency. If anyone learned statistics before, that's the mean, median, mode, or rataan dan median dan modus gitu ya. And then data dispersion, and you have variance and standard deviation and ANOVA. Those are like how the data disperse. Kalau di Indonesia disebut sebaran data, gitu ya teman-teman. Dispersion data dispersion means that you understand the variance, standard deviation, and ANOVA. Then the last one is skewness and kurtosis. So it's more deeper than the other things, so but still related into that data analysis format. Okay. Then we also have single variable graphical. This is just a way to plot data into one variable at a time, but plot it into like either histogram or stem and leaf plot or box plot. This one is a sample of box plot. This one is sample of histogram, which is, you have an X is the data value that you have, and then the y direction here, y axis here is the frequency. So how many data in these ranges that you have in the frequency in here. And this one is box plot, which is also useful because box plot let us understand the central tendency of the data, like the mean and then the median, and also the interquartile, which is quartile 1 or quartile 3, we can understand from this box plot. And also outlier. So for example, this one is data that has outlier. It's outside of the whisker of this line, is the data that has outlier in here. So another thing is multi-variable non-graphical. So this is a way to tabulate data into multi-variables, mean that we have more than one variable. For example, this one I have 1, 2, 3, 4, 5, 6. We have 6 variable together. It's just actually just like a tabular format. So you have age and then strength data from subject ID. Maybe this is from medical data. I don't know. Maybe it's some kind of like that. Then you can have some of the other parameters, and then you can try to correlate those into each other. And then correlation and categorical data, correlation and covariance data. So it's just more into like understanding the relation between parameters. So we can have those in this format as well. Then multivariable graphical is a way to plot multiple variables in one single picture like this. So for example, this one plotting age and strength, like the data that I show in the previous slide. This one, if we plot that age and strength, we know the relation that the older you get, the less you get the strength. So it's inversely proportional. The strength is going down the older you get in here. So which makes sense because that's what the we actually see as well. So hey, yeah, so this based on the raw data on the data that you got from measurement or from survey or from a questionnaire, for example, you can have some relation like this, and you can have this is scatter plots, and you can understand this correlation between two or more parameters. This one, like if you're grouping based on age group, you can you know the strength level of each group is like this, and you can make a box plot. Box plot is really useful because this way you can understand like which the data ranges between for example age 21 to 42 people have strength like this, like around 25 or between 20 to 30, but there's also an outlier in 35, which means like there's a people that really strong in this age. So I don't know what's the parameter that they used to calculate strength, maybe like some test. But anyway, just a sample of the data. So we know that this one is outlier than another data. The longer you have the box means that the data more dispersed. It has more variety in the data. But the shorter you have means that the data is concentrated into like a center value location in that. Close to the average value. So yeah. Then next, let me talk a little bit about supervised learning. So again, I talked a little bit early in the introduction for this lecture, but let me explain a little bit more here. What is supervised learning? So supervised learning is a type of machine learning that you train on labeled data. Labeled data means some examples on the data. So let me give a simple example here is you have different animals data that you want to label, and then you want like to build a machine learning model that you can that can classify the type of animals. For example, you have a bunch of cow, elephant, and camel data in here. You have pictures, but you know the labels. Labels mean like just what it is actually. Like for example, this picture mean cow, this picture mean elephant, and then this picture mean camel. Then we put that into the machine learning algorithm and then train the process. Then the machine learning will try to get the patterns between those. Oh, if it has black and white color, then it must be cow. If it has maybe gray color, maybe elephant and camel, and the brown one. So something like that, but just how we perceive the data. But machine learning is kind of just a computer, so they understand the data based on the number. So maybe every picture have pixels, and every pixel has value in it. So machine learning try to understand the pattern of that picture by, having all the patterns in the pixels. And after that, you can get your output like, it's elephant, it's camel, it's cow. And every time you have another picture, for example, you upload the picture to the model, and then the model will tell you, oh, this is elephant, this is camel, this is cow. Which is useful if you have, I mean, like if you only have 3 or 5 data, it's not worth the time to build this one. But imagine if you have a billion data that you want to analyze, and then you can put that into the machine learning model, and it will analyze those for you to classify those pictures of animals into like different labels, like either elephant or camel or cow. but can it work with other data? For example, if I have a dog or a cat data, can I do that? It might not be accurate because the training data only have 3 animals. That's kind of like that. So it's similar to how we as human learn. Like at school, we learn from example. So our teachers give some question and then teach us how we answer that with some example. And then we do that multiple times. Then in the exam, we try to answer a similar question, but not exactly in the same that we learn, but we try to understand those and try to answer those. So that's very similar. So what's the difference between supervised and unsupervised learning? Supervised mean you have something, some labels that you put to the model, but unsupervised mean that the data is unlabeled. But the goal is also different. For supervised learning, you can do classification, meaning that some simple example is if you have socks by color, you can try to classify those into different socks color here. This is red and yellow, for example. This is just, it's a simple example, but like what I mentioned in the previous slides, is also like example of classification and how you classify different animal pictures. Regression is a bit different because regression means that you try to predict numeric value of those. For example, this one is you divide the ties by length. Then you know that how to predict those. Then unsupervised learning is more like, the data is not labeled, meaning that we just put the data exactly as it is. There is no label. For example, like, we have a picture of animals, like I mentioned in previous slide, but we don't know if it's elephant or camels or cows. We don't know about that, or we don't have the data of that unless we do that manually. But we can let machine learning to decide to cluster it. It means that it will split up into different category based on the similarity between each of the input data that we give them. It can also do dimension reduction. It's a bit more complicated for this one. And then association is what the connection between data. For example, find what clothes I often wear together. So if we give the data to the model that we always use, for example, blue jeans and short t-shirt together, then they will see the association into that. So there's something like that. It's similar to what Netflix and Spotify use when maybe if anyone has experience on watching movie on Netflix, for example, you watch one movie and then the next time it will associate the next recommendation similar to the previous movie that you watched already. So it's kind of like similar process in those. So that's just more example on how we use the method. Okay, and then how we go back to supervised learning, and here's how the process on how we do supervised learning. So you need to collect the data and then do data processing. I explained this already in the previous section. So you process the data, then extract features and do scaling. After that, you put that into a machine learning algorithm, and then the machine learning model will try to learn based on the data that we give them. And also this data processing step is really important. Understanding the data is also important to decide which next step process into that. Then the next time we do the modeling process, we know we have everything correctly in here. Then we can evaluate the model, we can tune the model, and then we can repeat the process again and again until we get it satisfactory performance. I mean, like we get very accurate performance. Then it's easy after that to just deploy and monitor. Means that you serve that to client, to customers, or to everyone that want to see the results of the data. You can put that, for example, in the in the example that I gave earlier about classifying animals, maybe you can upload the model to a website, and then every time people want to know which picture is that, they know that whether it's cow or elephant or camel, yeah, something like that. But anyway, the three process that I would like to highlight here is data collection and data model training and model testing. So data collection is how you gather and process the data that are already labeled. For example, like animal data, you collect those, and then you clean data. For example, you only want to have three animals, but then you have data from other animal, like you have picture of cats and dogs. You don't need those. You just clean those. You clean and process the other data into the thing that you want to predict here. Then you do model training. Training is a process for a machine learning model to learn patterns on the data. Then testing is how you test the model on the new data that has been seen before. For example, you have like 1,000 data. You use, I don't know, maybe 700 or 800 for training, and then you use the remaining data for testing. So it has to be different, because that way the model doesn't learn the pattern. Doesn't learn the noises, but instead it will learn the general patterns into that, because we have a testing process that will test the accuracy. It's similar with when we learn about anything in class, teachers or lecturers maybe give us some homework, and then after you submit the homework, the teachers or the lecturers give you um, the answer keys. They give you the answer and how to finish those. But the next time in the exam, I mean, like, you already know the answer. The next time in the exam, the teachers possibly not giving you the same question like what you have in homework. It might be something similar, but a little bit different. But if we understand and can work on that correctly, then we get a high score. If not, then it means that we don't understand the materials very well. Then we need to learn that again. It's similar to machine learning. Machine learning, especially in the supervised learning process, it learns by examples that we give them to the model, and then it will, try to understand, and then in the testing process, it try to evaluate the input that we give for the test process, then give us some answer based on that. So that's the idea of supervised learning. Like I mentioned earlier, there are two types of supervised learning. The first one is regression. So maybe some of us already learned that in statistics. But it means that, you have a set of data. Like, for example, this one is Arctic Sea ice extent. So it's just um, how much ice you have in the sea, in the Arctic Sea, for example, in the North Pole. Then you have the year in here, and you see the drop, and then you want to try to predict those patterns. So you can use a regression approach, which is kind of a machine learning method as well. There's a lot of method. The simplest way will be like a linear regression, like this red line, or maybe second order regression. This is parabolic regression. You can also do this. It's quadratic regression here, so you can do this as well. And also there's also neural network can also be used for this case, but maybe for more complex data. This one is just an example of a simple data format that we have. It's just have a few numbers of data. Then there's an example of supervised learning for regression type, and this one is classification. So it's the same. The difference is the target, or the Y, is not a continuous value. It's not like this one is a number, right? Number is continuous. Like you can have decimal point. For example, this is 6.1. This is maybe 6.6. I don't know. Maybe you can have any number between this number essentially. But for classification, you can only have a certain categorical data. For example, like you can have breast cancer 0 or 1. Which one is more dangerous than the other? So based on tumor size, some larger tumor size mean like it's more dangerous, something like that. But it's just an example. And also like you can also have more than two category, like I mentioned already about animal classification. For example, that you can have elephant or camels or cows. Um, you can have three discrete data, but it cannot be anything between those. So this one, it can be 0 or 1, but cannot be, I don't know, 0.5 or 0.4. We cannot do that. So because it's just, it's just a discrete data, means that it's either 0 or 1 or any categorical data. So this one is classification. You can ask machine learning model to classify based on the input and output parameter that you have in here. This is more example of supervised learning method. So again, it can be a lot of things that we can have in here. Linear regression is the simplest one, and you can do a few iterations. For example, you try this one, it's not working. You try that one, not well enough, and then you put that together, and then this line is the best. So you use that as your model. It can also be decision tree process. It's just a type of method that you give a decision process on a for example, like this is animal elephant or cows, for example, and then the model will try to learn, decide, and split the process and see if you have different tree process, it's kind of like random forest approach. Maybe if anyone has learned machine learning before, in random forest you have a lot of trees like this, and then you vote together, and maybe XGBoost, there's also a method like that. This one is logistic regression. This is more into how you in your classification method. If you want to classify, logistic regression is the best, and one of the best, I think. And you can also use neural network, which is kind of like a more advanced method. It's more complicated, but it's the most powerful than the other data. But sometimes we don't need neural net, because if the data is too simple, it's not good enough. But if you have like maybe a million or billion of data, the neural net can work on that, given that we have a good computers or a good computing resources that we can use for that application. Okay, and then unsupervised learning is the last part of my lecture today. So it's basically, it's how you cluster a group of data which has similarity among members or or dissimilarity. So it's differences. If you see differences, for example, I have one set of data like this. The X parameter and the Y parameter is like this. Then I can ask a clustering algorithm or a clustering method from unsupervised learning approach to try to cluster like 3 clusters for this case. So it will try to, get the patterns of this, try to separate. So yeah, basically this one is one cluster. The other one is one cluster. And the other one here is another cluster. Based on this one is the X is high, but the Y is low. This one is the X is a little bit in the middle part, but the Y is high. This one, the Y is negative or low, but this one, the Y is like in the middle, like around 3 or 2 to 4. So we can apply machine learning method, especially in the clustering algorithm, to understand this pattern. That way you can understand, or you can have the clustering approach for this one. There are a lot of method on the clustering algorithm. the most popular would be like k-means. It means that it's something like this. It will find the centroid or the central of the data. Then it'll try to cluster those based on the centroid, and then try to find the closest neighbors. Let me go back again. This one I tried. This is you find the centroid, and then you find the closest neighbor to this centroid is like this one, all the triangle blue here, the blue triangles. And this one also tried to find all the neighbors in here, and it find the neighbors, and it not go to this one not go to this one, because this data is closer to the green data instead of yellow data here. So that's why it goes to here. So it depends on the how close is that to the centroid, then it can go from there. So this is more, again, there's a hierarchical clustering when you split based on different data characteristic, and then you make a division like this, and then you can decide which cluster belong to which. Then the last one is density-based clustering, is when you see which data has more density than the other. For example, this is blue and red data. It's hard to do the k-mean clustering on the data like this, because clustering means that, just for k-mean, it's just going to get the closer data to the centroid. But this one, it's better to use density based, because you have outer circle and inner circle here have different density base. Okay, I know maybe it's more complicated, but feel free to ask later. Any question if you have. Let me talk a little bit more about the clustering. For k-means clustering, there are two methods that maybe can be combined together. The first one is intra-clustering method, which is you maximize the similarity between the cluster inside the cluster. I mean, for example, this is green one. Make sure that everything in the green one here, the green dots here, have similar characteristic than the next one, and also minimize the differences or dissimilarity. So if you have differences between this, but it's minimal, that's good, because it means that you got a good cluster. If not, then you need to go to the different cluster which has more similarity. Otherwise, you can also use inter-clustering method. It's the opposite of the first one, on the intra-cluster method. Minimize the similarity between cluster. For example, the green one, the green dot here should have a different characteristic than the yellow dot. So you need to minimize the similarity, but maximize the differences between this. For example, the green one and the green dot here, and then the black dot here, it should have a lot of differences between those. But within the cluster, it should have a lot of similarities. That's the idea of k-means clustering. And let me give you some illustration on how it works. So first, you start with the, let me go back a little bit. Yeah, you start with the data, try to find your centroid first, then try to find the similarity between the data. Yeah, for now I cannot go back. Okay, let me go back and then see. First, it goes to here, then try to split to different cluster, because apparently this location is not a good centroid, because it doesn't have a lot of data located in here. But if it moves to here, the k-means can find a good centroid that can capture more clusters. So we have how many clusters in here? Like 1, 2, 3, 4. So this is one cluster. This one is one clusters. And then this is another cluster, and then this is another cluster. So we have like 4 clusters in here. So yeah, let me go back again, and so everyone can see the illustration. So here you move, and then try to guess or predict which the cluster location, and then here this one. Yeah, so an example would be like it's anything. For example, if for the weather data, you can cluster the similarity of the weather between locations. So like, for example, this location has more similarity with the neighbor location, but not very similar with the other neighbor location. So you can do as well for that example, or many other example actually. Okay, now we come to conclusion. So I think we still have more time later for discussion, but I would say that first, data processing is important. So if anyone wants to learn machine learning, please learn how to process the data first, how to understand the data. It doesn't have to be very complex. It can be just using Microsoft Excel. But if you learn more as you go, then you can use a more advanced approach, like using programming, Python, uh, R, or maybe MATLAB, or maybe any other programming process or scripting process languages that you can use, um, which can scale your data analysis into like big data later on. Excel is good for small data, but for bigger or big data analysis, you need to have some understanding in Python programming at least. Then we have supervised learning method that you can use that for your machine learning approach to utilize label data and then try to predict the results effectively. Then at supervised learning, it's good to have understanding unlabeled data. If you have data that is not labeled, it's good to understand those to cluster the data. And also you can also combine the solutions, unsupervised learning, supervised learning, combining with a good data processing and exploratory data analysis. It'd be good approach for machine learning application for that. So yeah, I think I have everything for this lecture. Let me know if anyone has questions. Okay, thank you. And
Okay.
then yeah, thank you, Bu
Yeah,
Widya. Yeah.
thank you very much, Dr. Rizky. It is a very interesting explanation. Well, we are waiting for questions right now, but while we are waiting, I would like to ask question about mindstem.idea. I was
Yeah.
checking the website, yeah, previously, and I could see that there are so many materials for learning. So,
Yeah.
can our students access to the website and maybe yeah, sharing their problems or their concerns about their project, something like that?
Yeah. Sure, yeah. Yeah, we have good mentor. Yeah, thank you again for the question. We have a lot of mentors and teams and collaborators across across US. So we have people from US, especially from Indonesia, that learn um, STEM in the US and then can share everyone with that together. So
Mm-hmm.
yeah. Um so if everyone to see, the website is free. We have a lot of materials and also free. And also if anyone wants to learn about more about STEM education or AI or programming, feel free to check our YouTube channel as well. And we also have some articles in website and also our Instagram. So I know like um Gen Z generation seem like prefer Instagram. So please feel free to check our Instagram or mindstem.id. We have a lot of training and we offer that for free, so everyone can join that and then get a certificate in the programming or AI or data science, WebGIS research as well. We have a research collaboration as well with universities. So yeah, thank you, Buvida, for the questions. I think everyone can access that and and it's going to be useful for everyone. So
Yeah, yeah, that's
yeah,
cool.
yeah.
Okay, so anyone would like to ask Dr. Rizky in person, you can raise your hand and talk directly. Oh, we have question on the chat room.
Oh yeah, I think I see
Abdul
that.
Aziz from Sense Data, yeah. Okay, okay, and we have please wait, Dodi Haryanto. We would like to start with the first question from the chat room first. Okay, so what are the critical challenges and best practices in preparing raw data for machine learning models? And how do these impact the accuracy and reliability of the resulting predictions?
Oh yeah, this is interesting question. Okay, thank you, Mas Abdul Aziz. This is the challenges will be like to understand the data because every data is unique. For example, maybe in ULBI, everyone learns about logistics, so you have a logistic data which may be different from one location with the other. So understanding those is important because um, sometimes you would like to use one parameters or one variable, but maybe not the other because you think that is more important than the other. So that understanding that is important. So I would say like choosing machine learning model is easier, but choosing how to clean the data is much more harder because if you have a really good data, any simple machine learning model can do that work easily. But if you have messy or really bad data, it's really hard to model those in the machine learning. So first, understanding the data is important, and then try to like what I mentioned, doing exploratory data analysis. That's a way to understand the data better, like the statistic of the data, the mean, the median, the modus. So we can understand those, and then that's really important to understand the data, and then we can put that process the data into the machine learning models based on that. So okay, thank you, Mas
Maybe
Abdullah.
to
Yeah.
Dodi Haryanti. You can
Oke,
ask question directly.
ya.
Mr. Dodi.
Thank you, Bu. Ya, halo.
Yeah.
Halo.
Ya.
Yeah.
Hai, Pak Rizky. Good evening for me.
Yeah. Yeah. Good evening.
Ah,
Yeah, Pak Dodi.
ya. Pak, my name is Dodi, master student in the logistic program at ULBI. Uh, I am currently learning about the how machine learning is used in the logistic, and I am also interested in the its possible risks. I ask,
Hmm.
in your view, what are some ethical or social concern we should think about when we use machine learning in logistics? For example, should we worry about the data privacy, job loss from the automation, or unfair
Hmm.
result due to biased data? Thank you for your time, Pak.
Okay, thank you, Pak Dodi. This is interesting as well because data privacy is a big issue in machine learning. And one thing that we need to make sure is, for data privacy, machine learning need to understand not the personal data, but the general informative data. So, for example, we don't need to put like private information like maybe date of birth or maybe um you know identity number or maybe an ICA number, something like that. We don't need to put that in the machine learning model. We can use that our database, but for machine learning model, we can use more like information that's gotta be useful for that model without any private information like that. And for the possibility of job losses, I don't think that is the case right now for AI machine learning. Maybe there's a movement on one type of job to another job, which is maybe good because with machine learning, it can empower people to use data better and then to automate the process better, which means more people will be needed into building the machine learning, maintaining the machine learning model, and maintaining all the system and also the data inside it. It's not, you know, I would say it will not into like the job losses, but more into like movement to one or transformation from one job to like better and better job in the future. So thank you, Pak Dodi.
Okay, thank you, Prof.
Yeah.
Okay, Mr. Dedi, thank you for the question. Let's move on to the second question, the third question from Mr. Muhlis? Mr. Muhlis, yes, please unmute. Okay.
Okay, thank you, Bu. Halo,
Yeah.
Pak Rizky.
Ya, halo Pak Muklis. Ya,
Good morning there.
ya.
I have question still around logistics problem. I just want to ask, do you have a specific experience in applying EDA at the logistic activity, maybe specifically in warehousing, distribution, and transportation? Right now, I think one of the tough problem is traveling salesman problem. It's one of the hard problem to solve. Maybe machine learning, all this ADA stuff can solve the one of tough problem in mathematics, how to get the solution of traveling salesman problem. Even maybe in Excel solver, it's hard to find out the solution. I'm just wondering if you have experience on such issues.
Yeah.
That's all my question, Pak Rizky. Thank you.
Yeah, thank you, Pak Muklis. That's a really good question. So yeah, I don't work in the logistic actually, but I do work a lot on the traveling salesman problem. So because I know it's a complicated problem because you need to have a good combination of parameters that you need to optimize to get a perfect or good solution for that. And also like machine learning can help with that. There's a of course like EDA is important because you understand the data and then we can understand the solution for that problem easily. But also currently like because the development of generative AI, it's also possible to solve that with AI. So um, so I did some experiment before with using chatbot like ChatGPT, but I wrote some Python script like to make it automate. So it's basically you can ask the chatbot to develop a solution for that, and then you can test it yourself, and then we can repeat the process and see if that's going better. So I did that in one of my work, and it works fine, and it can solve different salesman problem faster than people can do. So I think we can we can talk more details in the next occasion, but yeah, I think that's a possibility to use machine learning into that problem, Pak Muklis. Yeah. So
Okay, thank you, Pak.
ya, terima kasih. Ya.
Okay, thank you, Pak Muhlis. Okay, let's go on to more question. Sorry, more question on the chat room. Pak Rizky, we have question from Radityo. He said that there are several ways to build a chatbot for Indonesian language by using an API key from OpenAI, etc. A transformer-based model like Indobird's Cemiwiu, and then using a traditional method like SVM plus TF-ID. Which one of those ways really suit understanding sentences semantically with limited resources in terms of cost and computational resources?
Yeah. Okay, thank you, Mas Radityo. Ini interesting because building large language model is actually really hard and it's really expensive. Especially if we're building from scratch. I don't know, ChatGPT, I think it's $1 million or $1 billion development. So it's not easy for if we're talking about a small company or maybe just a small government institution. So especially unless like Indonesia wants to spend more on that, but for making Indonesian language chatbot, there the approaches that you mentioned, I think that's good, but for me it's the most cost efficient to fine tune the current model. For example, we have ChatGPT right now, but it's very generic. It's good for general language application, but for Indonesian, we only have, I don't know, I think I have the data, like Indonesian only represent about 0.7% of the whole internet database, which is, if we're talking about ChatGPT, maybe ChatGPT only has less than 1% of Indonesian language data, which is not good, because it means that ChatGPT learn better on English and maybe other popular language compared to Indonesia. But we can fine tune those, or maybe add more process into a model like ChatGPT to add more Indonesian data. So we need to generate more data, and again, it's related to the data collection that I mentioned. So we need more and more database on Indonesian languages, which it should be high quality data, not like maybe something like Bahasa Gaul. It's not good enough because it means like it has no clear grammatical rules, but more into like formal Indonesian language is also important. So we need more of those data. Then we can make or fine tune a model from OpenAI or from Google to get those. That's much more cheaper than building Indonesian language chatbot from scratch. Because if you build that from scratch, it means that you need a lot of computing resources to make it like at the level of ChatGPT. But yeah, other than that, other method that Raditya mentioned also good. I mean, like for me, it's just more cost efficient to use the current model and then add more data and then fine tune or maybe retraining on that data instead of starting from zero. So yeah, thank you, Raditya, for the question again.
Yes,
Yeah.
interesting. Okay, let's move on to our next question from Diki Sitepu from S2 Manlog. He asks, in the practice of building scalable and reliable machine learning systems in cloud environments, data management becomes a critical aspect. Okay, based on your experience, what are the biggest challenges you face in managing data, ranging from data ingestion and cleaning to data versioning for machine learning pipelines, especially where the data is distributed across multiple sources or cloud storage systems? And how did you address or overcome those challenges? What strategies, tools, or best practices have you found most effective in managing distributed and evolving datasets in cloud-based ML pipelines? Oke, yang bacanya aja udah
Yeah.
repot ini. Banyak
Iya,
banget.
terima kasih, Bu.
Iya, Pak.
Ya, ini pertanyaannya sangat ini ya, detail ya. Okay, let me try to answer those. Okay, thank you, Mas Diki. Okay, so basically in the challenges, especially if you have cloud-based data, I mean there are a lot of possibilities. The first one is of course the security, because in cloud-based data, it's possible for a hacker or maybe some hijacker that would like to inject some bad data into that system, or maybe try to get that system as well. So make sure that all the personal data and privacy not uploaded into the cloud data. That's also one of the challenges that I think I'm seeing pretty often for people, government, and maybe companies for that. And also, doing machine learning pipelines mean that you need to check those frequently. It means that when the model is already into the cloud, we need to make sure that it's been checked very frequently, like maybe every few hours or every few days, to make sure that you still get the correct results. Because usually the more data you get from machine learning, but then you didn't do retraining again. If you didn't do retraining again, the prediction might go the performance might be worse than the initial performance. So every time we have new data, or every few days or a few weeks, we can start on doing retraining on that new data. That way the performance still good for the new data, because data is dynamic, especially in the current situation. Especially we're talking logistics as well. It's really depending on the season. It's really depending on a lot of factors. So whenever the new data come in, it's good to retrain the new model for machine learning for that. Okay, I hope that answered the question, Mas Diki.
Thank you,
Okay,
Doctor.
Yeah.
Yes. Okay, let's move on to our next question from Julie Estumanlo. He asks, in what ways can machine learning be integrated into business and operational systems to deliver tangible value?
Yeah, this is a good question, because we have a lot of application of machine learning that maybe some of us didn't know, but it's already there in our usual daily life. Like I mentioned, in Netflix, for example, it can recommend next movie. On Spotify, email as well. It can recommend what email we need to read and something like that. So that's a lot of machine learning system into that. But for logistic, we can also try to automate a lot of processes with machine learning. We'll try to, so the previous question that we just discussed, is possible in warehouse, or to manage all the traveling road, optimize those, how we travel to one location to another. So it's also we can optimize those with machine learning, and then we can integrate those into the business operational system. So this is like machine learning in general, but more into like generative AI, like chatbot. A lot of companies already include that in the system. Like it makes things easier, because we don't need to have like a lot of customer services, but also make things more automated that way. For general questions, user can ask the chatbot, for example, like how long the packages will deliver to this address, so they can check the database, and then give the user some response, and doesn't need to go to the customer service very often. If the problem gets arise, I mean, like if we have like bigger problem, then the human will need to step in, like that. So I mean, customer service is needed for that. So it doesn't mean that we're going to lose more job for people, but more into like it will be the easy job that can be automated. We can get it automated, but more people will be needed in managing the system as well. So it will move from one type of job into another type of job, which is kind of like better and better system in the future. So that's some example in Mas Yuli, like that. So
Okay, yeah. Okay, let's move on to the next question. This question comes from a friend of mine, Ibu Dera. Ibu Dera asks, she said, "Hello, Dr. Rizki. I would
Yeah.
like to ask about how do human inputs and decisions influence the way AI respond to prompts?"
Yeah. Okay, thank you, Budera. Maybe this is related to chatbot like ChatGPT. But yeah, it's kind of like chatbot is kind of like unique, because it's been trained on a lot of data, or a lot of internet data, especially. And yeah, of course, like human input is important into that, and also the people who develop chatbot is already included some of the human inputs, because, for example, ChatGPT, we cannot ask question that is dangerous, or maybe that is has negative impact in the society, we cannot do that. So they already put some human input into that to control that behavior. But also we as a human, we can also, if we do prompting or ask question, we can also do we can also ask very clearly, then it will give us the response to that or question like that. So, but of course, like I found asking in English is better right now for ChatGPT, unless, like I mentioned earlier, that unless we have a very good Indonesian language chatbot later in the future. But yeah, I think we see some patterns that currently ChatGPT in English is way better than the other languages. So if anyone wants to learn English, I think it's a good time. So please learn English, and then it's also help us to ask questions to chatbot, because I don't see in the near future that any other language will surpass English, especially in chatbot, because all other internet language right now is mostly English. So and also neural network or large language model is trained on the English language. Um, so yeah, I think that's a good way to do that for putting more human input decision into the AI. So yeah, thank you, Budera, for the question.
Interesting.
Mhm.
So I think we are going to the last question from Taufik Alwan, and I'm so sorry to Fatima Zahra. Maybe you can ask Pak Rizky, yeah,
Yeah.
via email, yeah, for your question, Fatima. I'm so sorry. Okay, let's see Taufik question. How does the training and testing process work in a machine learning model, and why do we need to split the data? Oh. Why do we need to split the data into the trained tests or trained validation tests? I'm sorry, Al Marsyah Zikri, we are running out of time, so we cannot ask your question to Dr. Rizky right
Yeah.
now. Maybe you can contact him directly via email, or you can go
Yeah.
on to Mindstem. Yeah.
Yeah.
Okay.
Thank you.
Let's
Thank you.
answer the question.
Yeah, thank you, Bu Widya, again, and also Mas Taufik for the question. So, like what I mentioned, machine learning, we teach machine learning. It's like what we're teaching students. So, um, that's why we need to split the data into train and test. Because imagine that you have the same exam question like your homework. Let me put it in Indonesia. Nanti bayangkan loh teman-teman dapat pertanyaan ujian mirip sekali atau sama persis dengan PR gitu. Jadi nanti akan akan terlalu mudah gitu. Jadi nggak akan mengukur kemampuan sesungguhnya gitu. Makanya kalau dalam machine learning kita split the data jadi train dan test, karena train itu untuk bahan belajar, tes itu untuk bahan ujian gitu. Nah, mungkin seperti itu. Oke. Oke, thank you. Mungkin Mas Taufik seperti itu. Mungkin untuk yang lain, if anyone has more question, feel free to ask to mindstem.id. I think I shared the Instagram already. Maybe everyone will can go to there, and then we have a team that will answer question as well. So don't worry if you want to have a response in faster time. So I think it's better to contact them already. So thank you. Yep.
Okay, thank you all for the question. So we are reaching the end of our lecture for tonight, but before we end it, Dr. Rizky, would you like to make a final statement?
Okay, yeah, for me, thanks a lot for the opportunity for me to talking here with everyone from ULBI. This is a great experience, and I have a lot of great interest here for everyone in machine learning, AI, and also data analysis. So I hope that everyone can have a good career in there, and hopefully can use more of machine learning, AI, and keep learning about that. I'm happy to help in the process. So we have mindstem.id to do that as well. So yeah, feel free to reach out in the future if anyone has more things to discuss. Thank you. Yeah.
You are very glad to have you here. Maybe you can invite us to USA, to Purdue University.
Yeah, yeah, maybe. Yeah. Thank you.
Okay, allow us to have a photo session before we leave. Please, everyone, open your camera. so we can have our photo session. Oh, okay, so we have Mr. Julie over there who has asked question. Hello. So finally can see your face. Okay, is everyone ready? Is Mr. Rector here? Prof.
Ya, ya,
Yes,
ya,
okay.
masih di sini, Bu. Thank you.
Okay,
Terima
thank
kasih,
you.
Pak Rizky.
Yeah, please, Mr. Operator, lead us to the photo session, please.
Yeah, we will capture.
Yeah.
Okay, first screen. And second screen. Right. Okay, done.
Okay, then. Okay, so thank you to everyone who has participated in today's UBI Global Lecture tonight. And also, once again, we extend our deepest gratitude to Dr. Rizki for sharing his knowledge and sharing his time with us today. It has been a great honor. To all students and attendees, please don't forget to fill in the attendance form to get the certificate. Let us continue to support global education and cross-cultural collaboration. Have a wonderful night and a great weekend, and see you all at our next global lecture. ULBI, best talent, bright future. Thank you. Goodbye, everyone. See you again.
Thank you.
Thank
Thank
you.
you,
Thank
Pak
you.
Rizky. Terima
Thank
kasih.
you.
Thank you.
Bye-bye.
Yes, sir. Yes, sir. Yes, sir. Thank you.
Recording stopped.
Terima kasih Bu Widya. Stop
Terima
streaming.
kasih semuanya. Good night. Have a nice rest for tonight.